So the story today is to unpack some approaches that essentially impact the life cycle of software delivery. And I know that there are various attempts at reconstituting what the practice would look like. And this is our initial attempt at presenting some kind of practice that we think needs to be considered when an organization embarks on whatever journey it is. It's got a very strong AI-driven approach to it. So the basis of this is that we come out of a world where the thinking was done almost entirely by the human and the doing was done by assisted tools since the beginning of the software world. So that means that code generation tools and case tools, so that means computer-aided software engineering tools, 4GL tools, have been around for a pretty long time, and every wave of invention attempted to solve one primary problem. Can we take the intent of what a person wants to achieve in the context of their business, and can we turn that intent into running software? That is what the sub-industries that have existed focused on fairly heavily. We're now in another cycle in that world where what we're seeing is that with a new wave of tooling, you can accelerate this beyond what we thought was possible before. So the thing is that the concept of the different kinds of AI tooling, and in this case, we're not going to talk about any of the other kinds of AI, purely about tools that generate tokens. So that means that the economic model of what you essentially, or how you are dependent on your capability essentially is measured entirely in token production. And the reason why these business models are organized like that is because the job of the AI is to generate the next plausible token that is most useful in the context of the target that it is going to be applied in. And that's why you'll see that it doesn't matter if you are Anthropic or if you are OpenAI or if you are Google with Gemini or if you are Grok or any of the providers, all their business models are wrapped around the construct of, can I invent a model where the economic cost per token makes it worth my while to sell that as the primary service, because that is essentially the core part of my business model. So that means that the ability to generate any kind of software is definitely not free. At the recent NVIDIA conference, Jensen said that a software developer should spend at least $100,000 or more per year, and that was per month, on generating whatever outcomes. And if you're going to use OpenClaw or any other tooling like that, you'll be using hundreds of millions of tokens per month. And that means that the cost is pretty big, but it's still better than wanting to do that with an army of humans. And we also now know that the mistakes that were made recently in productionization of software and the like was almost entirely because there were humans in the production line or in the DevOps or MLOps or AIOps process that caused most of the issues. And we're now moving into a world where we're trying to automate that so that it's a lot easier to use. So this really what we've been trying to work on is to say, well, how do we take words, explanations, ontology, domain engineering, and turn that into running code? And that is the core part of our story. So the basis of it is that we come from a world where the human was the primary bottleneck in the intellectual journey to produce an outcome based on a design. So systems analysis and design and the practices that came with that were all essentially wrapped around the construct that the human performs all of the thinking and all of the work. So if you were a requirements engineering person, an architect, if you were a person that is ahead of a design that you need to implement, whatever that might be, or you're head of integration architecture, all of those disciplines are all under pressure as you now find that a lot of the capabilities can be automated if you have the right infrastructure in place to do that. The second thing is that where we today, developers co-write with co-pilots or with some kind of co-inhabitation with an AI tool to be able to produce an outcome. And that means that the model is designed to charge the client for a certain amount per month, a certain number of tokens, and you must be able to consume those. If you solve the same problem over and over again, you basically get charged to solve the same problem over and over again. That shouldn't be the case. So how do we short circuit that capability going into the future? And that means in the future, the ability where the developer can come up with some kind of idea or a spec the agents will essentially build everything for you. So the act of intellectual labor is being now replaced by the various types of agents. Now, there are questions like, are we going to need developers in the future? Are we going to need architects in the future? Yes, we will, but we're going to need the people who have an understanding of what the business does all the way through into the detail. It's not going to be necessarily that you only specialize in one fraction of what the capabilities are normally needed to get the job done. We see that this level of specialization is going to go into quite a different level than what it was before. So that means that the tools that we now use to compress this time need to go through some ways of thinking about it. And one of the first things is that how do you take the thinking of a requirement or of something that you want to do into a design, and why would you want to do a design in the first place? The reality is that if you deal with enterprise systems or organizational systems where you are trying to contain and manage your risk, you cannot just get away with trying to save your data in an unstructured way and make mistakes continuously. The cost of the mistake is way too high based on the benefit that you're going to get in the long term. So that means tabular-based data, and even if it's in a document database style data that you know that needs to be reliably the same, requires a design. If there's a certain system practice that's got to do with regulation or rules that are in your business, you want to make sure that the design is pretty standardized. And then the reasoning is that how do you use the thinking of the journey that you're on in order for you to figure out how you're going to deal with this lengthy design and compress the time as much as you can. So by the time you validate your vertical or horizontal capabilities, you want to be able to say, well, I want to be able to go all the way through from a high-level business requirement all the way through into a detailed technical practice, or I want to be able to look at a workflow from front to back and understand how all of the components fit together. And then the implementation, you want to be able to automate. So it's not just about knowing how all the elements necessarily work together, but you want to be able to push it into a production environment where you can test and perform all of the things that you think that are going to be needed to make sure that it works successfully. So this is a paper that was published by Anthropic around a self-assessment that was performed some months ago on developers that were asked questions around the time and how the time was impacted and the volume of output expected. And basically across the board, the volume of output is in a positive state across the entire life cycle. So it doesn't matter if it's debugging or code understanding or implementing new features or writing tests or refactoring, or every single part of the software development life cycle at some point has been affected by the level of automation that exists today. And I know that in our business, we've got some tooling now and products that we're working on that essentially is generated 100% by our own AI tools. So we now know that ability to accelerate the outcome is obviously one of the primary priorities for most organizations to get their minds around. You know, how are these different tasks then affected? Because the frequency of how often you perform these tasks, let's say a year ago compared to now, and this is from late last year, we can see that especially something like implementing new features is disproportionately more productive than we've ever been. So that means that if you look at GitHub and the like, you'll see that there's this flood of newly generated systems that have not been vetted, authorized, checked, or audited by any human, but you have tooling that can do that for you to see if it's going to fit your current situation. But you don't know how it works. You don't know if it's going to function properly. So what would you need to have in place in order for you to solve that kind of issue? So the way we're seeing is that the new life cycle typically will contain these kind of elements. So if you are hypothesis driven, that means that every prompt and tool or whatever you use must be seen as a versioned experiment. So every time you have got a design that you created, you want to be able to snapshot it. Every time you snapshot it, you want to be able to learn from that. And you want to be able to then take the comparison of one version to the next to understand how your model is evolving. It needs to be spec-driven. So that means that can I take a natural language environment into a design where it can generate the design for me, where your job then becomes one of, can I read, let's say, a UML class diagram or an activity diagram, sequence diagram, state machine, systems package diagrams? Can I read these diagrams that have been generated for me, because they will then be used later on for you to be able to create some kind of deterministic output where you will then define what you want the variations to be. So we'll talk about that a little bit later as well. The other thing is that you want to be able to validate right up front. You want to be able to check that the design that you are busy creating already complies with what you expect from some kind of final outcomes. If you design an enterprise system like an HR system or a CRM system or anything of the sort, you want to make sure that if you're going to have a customer lookup that has to be validated, that the validation is going to happen, that you don't have to go and burn thousands of tokens and hours of time trying to get the simple things that we already know that systems need to adhere to go and do that from scratch. You want to be able to get that initial design done, get it generated, and then extend on top of that. And let's say you built your first system, you can still use your Claude Code or your Cursor or Windsurf or Pi or any one of the tools that you prefer to then extend it, but you want that tooling to come with a set of rules predefined. You want like a Claude.md, or you want a .cursor rules. You want these already to be created for you based on the infrastructure that's there that complies with the rules of the environment. So if you then create a self-healing loop or a rule around your self-healing, you want to make sure that it only fixes the areas that are fixable, not mess with the parts that you want to standardize and you don't want any impact at all. So that means you work from a scaffold-based environment. So the idea is that you have a standardized kind of plan that you have in place. It must be able to verify that it has been implemented, and you want to be able to refine that loop over time. And at the moment, we do probably 2 or 3 releases per day of the ecosystem code stack. And we know that as we add new features and new dashboards and new capabilities, that those are being extended continuously. And the last one that you'll see that will evolve quite radically over time, and that's what happened with products like Lovable and so on, is that it initially started with a highly specialized, let me do a web only. And multi-objective is essentially one of the core strategies I think that most AI tooling companies are following today. The ability to generate multiple types of businesses over time, or multiple types of outputs over time, depending on what the requirement is from the user. And if you cannot generate it, the idea is that you should be able to say to the user, I cannot generate this. So you'll see that today in ecosystem code, we're not so good at that. If you ask it to generate you an arbitrary app of some sort, whatever, it will still attempt to create you a business style system of it. It won't go and generically create you an application based on a prompt that is very, very, far outside of the core focus of what the tool does today. So we're all working on how we will update that kind of over time. So this is the story. The story is that how do I augment and don't replace the whole time? And this is what happens with almost all AI coding tools, is that you spend an enormous amount of time wasting huge number of tokens and hours regenerating, recreating, and fixing things that are kept on being broken. If you think about historic artwork, and still today, if you don't give it very specific rules and you keep on treating it on the one end like it's a PhD with knowing all of the world, and the other end like a 10-year-old that you need to tell exactly what to do moment by moment, you get bored of that. You get intellectual overload. You get really frustrated with the way that things work. So that means that you want to have a deterministic architecture that is provided to you. And if you go to the ecosystem code website, you'll see we explain a lot of these capabilities. So the idea is that the scaffolds, the outputs, the capabilities, you want to be able to understand those. If it fits within your focus, you can then take those as it is, and you then want to extend them from there. The other thing is product line discipline for us means that we want to be able to separate commonality from variability. Commonality means that items that are highly reusable, like data, or highly reusable, like business rules, or in some cases all the way up to analytics. And then when things get incredibly variable, like I have a user-specific requirement for a form, for a front end, for a certain report that must be done, or whatever it might be, you want to be able to change that or add that capability without breaking your base. You don't even want your AI to go there. It must only work within what the rules are you have set right from the beginning. And typically things like user interface and so on is the one part that differentiates one product from another, because the back ends, most people don't even see what they are. Okay, so when you then decide, when you kick something like this off, how do you get it done? You want to start with a very disciplined kickoff. So you want to be able to have a very good understanding of what it is that you want to do. And you want to be able to have a domain or a product line approach that we describe it here. So if you have a domain or an ontology that you work from, and you know that there's a certain type of language and a certain set of relationships and rules that need to be in place, and you describe those really carefully, you might find that a lot of tools can generate these for you pretty reliably. And we generate it also for you inside the tool. You literally have to just give it a one-liner, and giving it a one-liner will produce whatever the output is that it can produce. So what I could do as we kick this off, and we're going to get into a demo in a moment, I'll show you these kinds of concepts get generated and how quickly it is for you to start those when you understand what it is that you need to do. The other thing is, what you want to make sure is that you have some kind of story of your delivery worked out up front, so that the agents that you're going to generate. The idea behind the ecosystem code backend is that it generates you a full MCP stack. So you can integrate whatever was generated from us directly into any of your existing tooling environments, or you can even use the ecogentic tooling that we have as our own MCP tool to wire these together. You can create that whole environment out of the box that you can start testing it from the get-go. We will be publishing testing tools that come with the tooling over time. At the moment, some of the testing has still got human in the loop. There will be automated tests that are generated with the total code base that will come over time. So in order to achieve all of this, we figured out that we need what's called a seven-pillar system. And the seven-pillar system I'll work through in a moment. But that just means that how do you create a reliable autonomous system? And this is really the basis of a lot of what we trying to figure out. And these are essentially how the layers work. So when you start with some kind of pre-gen UML that is being structured and created for you up front, all of that pre-generation gets done through the tooling. And after this, I'll show you a demo of how that whole process works and how you kick that off. The second layer is the fact that you want to have some kind of deterministic post-processing. So that means you want to have a zero-cost-based access to a deterministic framework so that you don't burn tokens to do the basics for you. You don't want to burn a token to create a user interface framework, a backend, a database access. You want to make that accessible so that you can start working on the parts that are unique to what you want to do in your business. And that gets you to the third layer. And that means that how do you validate anything that you're going to want to do that is automated checking? And that means that how do I make sure that it is secure at the right level for the right purposes? So by the time I get to the self-rectifying loops, especially when you integrate with enterprise data environments and so on, you want that loop to make sure that it keeps the knowledge of what it's working on. And so by the time you then generate, let's say, your Claude.mt or your tasks or any one of those for additional AI tooling, on top of the source code that was generated, you know that that is already in place. The other thing is you want to have fallback behavior. And the fallback behavior is in when things go wrong, you want to have a fallback so that your entire stack doesn't come stumbling down, especially in the enterprise setting. So that means failure needs to be isolated, especially in the context of your commonality versus variability in a vertical stack. You want to be able to do diagnostics across your pipelines. And then lastly, you want to be able to deal with some kind of human feedback, human in the loop based environment where a human can go and fix a certain piece of code. So in our case, what happens is that the code stack that is generated requires no additional runtime capability. So you can take the outcomes of what is generated and you can directly start extending it based on whatever the capabilities are that you think are useful for you to then extend that particular environment. So let's quickly drop into a demo and I'll show you what this looks like. If you go to ecosystem code, you'll see that on the website, obviously it explains everything pretty clearly. And if you go to the blogs, you'll see that there are a whole lot of technical details around how everything works. Or if you go to how it works, there are some examples that explains how the entire cycle works end to end. So in this case, let me just log in. I'm just going to go into my Google account. You'll notice that as I get in here, that there are a whole lot of experiments that I've already run myself. I generate an enormous number of systems continuously. And then often what I do, because it's connected with my app, I've cleaned up probably 20 or so systems every 2-3 days, just to make sure that we keep on testing everything properly. So I find that in this context, if I want to test a new idea, like in this case, there's a banking CRM system or a Sage accounting or restaurant management or QuickBooks or shop platform or Microsoft Dynamics or whatever document management system I want to regenerate, all I do is I go to my phone and I tell my GPT that it needs to do it for me. So that means that I can kick off a project if I just link it to an agent. Okay, and maybe what I'll do is let me just connect to this machine and I can show you what that looks like. It should pop up on the screen any second. So in this case, inside, oh, I have to approve this. Come on. It should approve it any second. So just check here. Oh. Okay. Anyway, it's not connecting today. But what you do is, for those interested, you can just go and connect. If you go to settings and you go to server connectivity, you can go and pick either OpenAI or companies like ChatGPT and the like, and you just connect to this server, it'll validate it against your username and password from our environment. Or if you want to connect to something like Claude, you can generate the key here, JWT key, and you just give it this script here. And this script is the script that is the MCP standard script supported by almost all of agentic-based tools. And you can get it straight from your account once you've created it over here. The other thing to note on my account here, you can see here that I've got 104 million tokens that I've used in the last few weeks for testing. So I normally reset these every 100 million or so. So those will go back to zero probably the next day or so. And the idea is that you can generate a full CRM system, give or take, with about 200,000 tokens. So the idea is that you can keep on generating new ideas at about $30 for 1 million tokens, because a lot of the deterministic capability already creates the backend for you. So what I'm going to do is just kick off an existing generation, and then we can go look at some of the new ones that are there. So when you want to generate a new system, and we're just going to make one up for now, we're going to just say Vitality CRM or something like that. And what happens the moment you given it a name, it claims a name. So if I did it from any of my other tooling, it would have worked the same. And I'll show you now what the other options are. I'm going to say to it, create a CRM system for a company where hotels, gaming, and travel must be included. So now think about just how generic the statement is. What it does, it knows in the context of its domain engineering capabilities what customer relationship management is. It knows the fact that you talk to a certain industry, and the fact that it refers to 3 different constructs. When you do the analysis will take the domain and ontologies that are currently in the backend, and those will be extendable over time. And we're not going to talk about it today, but the idea is that there will be some kind of ways in which you can maintain any kind of ontology connection to whatever the generation is that you're busy working on at the moment. And you can see here that it's now created the outline of what it thinks is needed for me to generate this. So there's a domain model, that's my class diagram, the booking lifecycle, create a hotel booking, create a gaming booking flow, create travel. So it's made a certain number of assumptions about the domain that I'm going to generate for. And let's for now say that I'm not going to want to change this, and I just want to generate this from the get-go. The process will kick off now, where it works iteratively through not just the domain and the language, but also through all of the capabilities, and it goes through that 7-stage cycle all the way through to the end, where the human in the loop will just be the fact that I have to review the design at the end and potentially make changes to it before I produce some kind of system from that at the end of the cycle. So while this is going on, let me just go show you what something else looks like. If we go back to ecosystem code and we go to App Studio. App Studio is a version of our tooling that kind of fits into the lovable kind of stack, or companies who've got this kind of feel. And what you can do is, if you set a project, and let's say we go look at this banking CRM system, and you set a project, you can then have a conversation with that project, similar to what you can do if you do it over ChatGPT or other tools. So I can just ask it to show me the class diagram. So what will happen is that all of this now, because you can generate the class diagram or any diagramming for that matter through any of your generic AI tools anyway, but this is part of a broader system of design that exists. So that means that in this case, this customer, with all of the details of its operations and so on, by the time you expand it, you can see that this particular one was generated based on what a bank normally would need from some kind of CRM environment. And you can then extend your class diagram here if you need to, and it'll then know immediately by the time it generates the code what this diagram should look like, or what it is for whatever the target is that you're working on. Okay, so while this, you can now see here that it's going through the various stages, generating more and more content. So while this is going on, let's just minimize that. Let's just go back to jobs and go look at one of the other ones. If you look at that banking CRM environment that we looked at earlier, what you can do is you can view any of these diagrams in whatever format. So the idea is that you can go look at your diagrams that were generated and decide if you want to change those or not. And all of the diagramming capabilities in our tool, if you use it out of the box without using generative tools, are free. So if you want to create new designs and use them, it's not a problem. You can just go and create them and use them if you don't use the generative tools. So that's where the interface of the SaaS world and the new world are basically coming together. In the old world, you used to charge for these kind of things. Now, the only time that there's a bill to be paid is when you use the intelligence that's going to be added to whatever it is that you are working on. What you'll notice here is that there's at the top a button called Document. If you select Document, you can generate an enterprise-style document in Markdown, PDF, or a Word document format. So if you want to extend it or you want to communicate with a client on whatever this environment is that you're busy creating. So you'll see there's a business, a design, and a technical document. So for now, let's just select technical document. Let's select all three. When I now start the generation for that, what will happen is that an additional job is added. There are 2 jobs running. And what we will do later is we'll just look at what the results look like when I get back from the presentation in a moment. Okay, so the big thing now, what you'll notice here is that this token count will go up. So at the moment we're sitting on 104,347,000 tokens. And when we come back, we'll see that that will be higher because it's now using the tokens for those jobs that are currently running. Okay, so that means that just taking my initial thinking, generating it, or go look at what I've generated previously, I essentially can get all of those pieces done automatically for me so that I don't have that classical intellectual labor of creating a lot of these documents and everything that I need to get done. So now there are 7 foundational practices. There's continuous experimentation. That means the ability to continuously generate new capabilities, new systems, rather than writing tiny pieces of code and hundreds of prompts and hundreds of plans and keep on doing the same job over and over and over again with very, very little result because you burn so much time working on things that just never work. And you keep on telling it to fix, updating your prompts and everything like that. It's just an enormous amount of work. So the first thing is you want to do continuous experimentation of the entire requirement of what you're working on. And once you've generated it, you can then use your existing AI tools, like I said earlier, to extend it. The second thing is you can then decide on the options. You can remove classes, add classes, you can duplicate your projects. You can also create multiple versions of projects that you then can snapshot and you can work with those. So that means that you can decide how you then iterate over whatever it is that you're working on. You want to do vertical and horizontal validation. So you want to do from front end to middle tier to back end execution. And you want to be able to validate the entire generation of whatever stack it is that you've already created. And when we export the one we're working on now, I'll show you what that looks like when we go and generate the code for it. You want to be able to do rule refactoring. You want the rules to be generated inside the tool so that they're prepared for you, that you already have that capability in place and you can then execute on it. You want to be able to make sure that the quality is right. The latency and the tooling already takes care of a lot of the architectural capabilities. And the self-healing, especially in an enterprise system, means that when you generate a module or some kind of addition, it must keep on fixing itself until it delivers on the intent that you want, without you having to go manually fix a whole lot of content. And the last thing is you want to make sure that there is a scaffold already in place for you. So that means continuous experimentation. In the agile world, it's got to do with sprint planning and hypotheses and long cycles of documentation. And it's basically Confluence documentation everywhere for you to, now what you want to do is you want to take the idea straight from there into something that's already run. So that means it doesn't matter if you want to run it into Bedrock or Azure, whatever the back end is. You can configure that in an enterprise setting. If you use our public product, then we already have a backend configured that is optimal for the kind of cases that we think that are normally really useful for that. So that just means that your ongoing experiments and whatever tests you want to run must be done. Your option selection, like I said earlier, the new Agile workflow, you want to be able to generate multiple architectural options all the time, and you want to be able to orchestrate across those. And then in the ecosystem side, you want to be able to make sure that you can decide how you want to specialize the diagrams that are being created. So if you then want to, let's say you want to create sequence diagrams or you want to create process diagrams, it knows that it has to create the class first, and in the class it needs to validate a certain value, and it knows how the elements link together to make a complete design that is consistent. Otherwise, what happens is that if you just let the thing generate for you, you keep on having to give it that old context, and we find that the amount of work that goes into people doing it by hand is just enormous. You just find a lot of hours are burnt on not getting the right capabilities. Okay, so the vertical and horizontal validation. The pre-generation is make sure that your diagrams are already formed, they're already created, they're already out of the box available for you to use. And we use LLM as a judge, so it keeps on checking that it's doing the right thing, and it makes sure that it validates its own tests through a multi-layer architecture that keeps on checking that everything is done. So it's essentially using our own agent ecosystem with our own MCPs that keep on checking what needs to be done depending on the architectural stack that you're going to target, especially when you start generating a full stack output at the end of the cycle. Then your rule refactoring, you want the rules to be generated inside your tool, and I'm going to show you now what those look like so you can get a feel for those. And at the end of it, you will then know that by the time your source code gets downloaded and you connect one of your AI tools, it'll pick up the fact that that exists. You often will find, like an example with Claude and so on, that it'll make some mistakes and it will then ask you to correct it, and it'll then do that for you because it will know how to integrate. And then your quality optimization is just make sure that your correctness and latency and everything in your architecture are really taken care of, because you know what a lot of those good practices contain and why they are really useful to have in place. And then self-healing is to figure out which patterns are more successful than others, so that the pattern that gets used in the right area is delivering on the right kind of fix. So the idea is that once it's been fixed, it then needs to remember what the fix was, so the next time that it does it, it won't make the mistake again. Most of the prompts on the public product you'll see is automatic feedback loop. So that means it will go back into the base. If it's an enterprise, it's entirely isolated, so then it only runs within the organization. So there's a different cycle for the enterprise than for the public version. And then the big thing for us is that there are baseline scaffolds. And that means that there are a whole lot of base capabilities already in place that you can execute from. And that means that the same way with you think about the admin dashboard in the context of a front-end tool, whatever it might be, all of those are kind of pre-set up and created for you. So if we go back to our tooling and just go look at how far we are, so you can see here that there are a whole lot of jobs running, and our document job has probably already concluded. We can just download that document, and you can see there that it's got a technical document that we can now download. And let's just make sure I'll give it a different number, and we can go open it. So in the technical design doc, there's a certain template that is used. You'll see that in the future we will add template formats that you will be able to add to what you want to generate. So here it tells you about this particular system, an executive summary, and an overview. And in this particular project, there is one where a certain diagram has got an error, and I just want to show you what it looks like if we get to that. But there's a diagram inventory, class diagrams, state diagrams, sequence diagrams, activity diagrams, component diagram, all in one final deployment. And then I'll show you at the end, because this is a technical document, it will also show you your cloud target architectures for AWS, for Azure, and for GCP. So now it takes you through the domain model, the customer, in this case, because it's a CRM system, so it'll have a customer. There's the domain model, the class diagram. These are the state diagrams, like there's the lead lifecycle, opportunity lifecycle, support, customer onboarding. And this is what it looks like if the diagram has an error in it. Okay, so it will then make, and you can see there, this is a plant UML generation for the UI purposes. Where and on the app for editing, we use a different format, but this is great for printing it out. So you'll see that you need to go and fix the diagrams when this happens. There, it continues with the life cycle, all the elements that you would need for this requirement to be approved. And then you get to the activity diagrams. There's an opportunity to sale workflow. So it shows you, like in this case, if you look carefully, the relationship manager, the product specialist, CRM system, credit analyst, customer, because this is in the context of a bank, it talks you through the entire cycle, including the decisioning that the domain already figured out for you. Like, here's a KYC verification and where you would use it, including if you wanted to do OCR or interface with checking that you got all of your capabilities in place, because in this case, the requirement called for that kind of environment. And then as you get to the end, you'll see here that it'll then start showing you the implementation details. And we are working on extending this quite significantly, depending on the options that you select during your project configuration. And I'll go show you now what it looks like. But in this case, you see there's a front end, your API database, your cache environment, and everything that's needed. And it shows you what your AWS structure would look like, what your Google Cloud environment would look like, and then also what your Azure would look like. So it essentially creates that entire architectural documentation for you so that you can get those approved. And then the other thing that is quite important is that it also tries to guide you into how you can then take this, what has been done, and turn it into a new style of delivering a project. So generate first, then extend, the new Agile. So it explains it, and it talks to how you would deal with a deterministic-based environment versus the AI enhancements that you've made through your own extensions, how you iterate through an example when you change models, when you would need to go through a regeneration or whatever you want to change, how that would work. The recommendations for your next actions, how do you validate and generate a full stack, verify your sequencing, and everything. So it basically takes you through the entire cycle of what would be needed for, in this case, a design to be approved by an architectural committee or by a business team or whatever it is. In this case, this is the more technical document. So in the business documents, the language in many cases is a bit different. So you can see this project is still running. It's still generating for us. But what I want to do in the meantime, let's just go out of that. And I want to show you just a different project. If we pick, let's go back to this particular system. When you generate, you'll see that there are a whole lot of options that you can select when you generate the project. Maybe the first thing to show you is that in project context, you can set the architectural defaults for the code that you want to generate. So you can decide if it is a React or a, let's say, an API only based environment, or you just want to inherit from your defaults that you set in your own user account when you set up your properties right in the beginning. It's got React and Vue and Seaside for the small talk people. And it's got on the server side a whole lot of different options that you can use with various kinds of options. And then it's got on the database a number of databases. So you'll see that a lot of the cloud native databases we are working on. So the idea is that you want to be able to move it from, let's say, a local SQL server to an on-prem SQL or whatever it might be. You can then configure that through whatever the target project is that you want to define. The other thing that you can also do, like you can see in this case, in this particular, it's quite a, comprehensive design, but you can go and create diagrams manually. And let's go and create a diagram for, let's say, UI for customer. We want to create a new one, and we go pick up on the UI wireframe. The moment we create a UI wireframe, you'll see that the canvas is empty, and you can then go into that diagram. So here's the diagram, and we can say, well, we want to generate the UI, and we want to generate the UI from the customer. Let's say we want to take the customer from the class diagram. So we're going to look for where it exists on that's the customer profile. Let's just quickly check where the class is. So you can see here, it tells you what the diagram is. So let's go pick the class of customer. Then we're going to say, well, we want to create a new customer edit with, let's include leads, and opportunities. And when you generate it, what it'll do now, remember that you only get charged for when you click generate. That's the only time that your token count goes up. But you could have done this entirely by hand if you wanted to do it by hand. But the idea now is that it's generated a new form for us that follows kind of like an enterprise scaffold structure. When we go and later generate this app, you'll see this would be added to the primary app. So if I go and I say generate the code now, the defaults are picked up what I've already defined. You can specify if you want to have additional security options. And yeah, I'm going to say to include Claude, a prompt environment, as well as because we later want to maybe use it for something different. In order to check that, so let's say now I've added some UI, I've checked my designs, I've gone through some of my workflows, I've checked through my design document, and I want to go and make sure that this is now prepared by the architect or the person who's responsible for the generation capability. You go to contextual prompt, and I'm now going to go add, and I want to generate cursor rules, because let's say cursor is the app that I'm using inside my company to extend my coding, or I want to go to the cursor prompt and Claude rules or Claude skills. All of those can be generated from the design that you've already created. And that's what spec-driven development and spec-driven AI is all about, is the fact that you've got the full specification predefined, you understand what it is, and you build and extend everything that you do on the back of that. And the same thing when you go to Claude rules, and I generate those Claude rules, all of those can be added then to your export when you then go and generate the app, and you want to make sure that it's all available for your final running of whatever the app is that you're going to be building from this. So what I'll do while that's going on, let's go while that thing is generating. It will take about 25 minutes. It's going to be too long for what we want to do. And we want to go generate the code. Let's go pick these options anyway, because we know they're being populated. And we're going to say generate application. Now what happened with the application being generated? You're going to see that it's incredibly quick. And the reason why it's quick is because it takes the deterministic part of what we configured. And you would have noticed that in that particular app, there's one plugin, and that UI that we just designed will now use the generation capability that sits on top of the existing architecture. Okay, so that means that it will not break what sits underneath it, even if that form made a mistake or something went wrong in there, and you later go take your AI tools to go and extend those. They will be done independently of what sits under the covers. Okay, so while that's running, the shifting thinking then is essentially that historically you do sprint planning. Now it's about hypothesis planning to say, well, do I have the right thinking of the system that I'm creating in place? It's from daily stand-ups to some kind of telemetry check. So that means, can I generate 5, 6, 7 per day and review them on the hour instead of having to do it every morning or every day? Can I deal with the sprint review? Typically in our world, it's a quality score, it's a token efficiency. Have I created the right kind of scaffold environment that is efficient for what I want to achieve? The retrospective comes from making sure that you can check your prompts, and especially when you look at my great rules that were created, if you want to move from one system to another, how many systems have you generated? What are the challenges with the ones that you've already created? And what do you need to do to be able to get a design, some kind of spec-driven environment that's going to work for a target? All the way through to like your DevOps, where the idea is that you want the system to be self-healing. It must be able to fix until it's correct. Then you baseline it and you maintain it once you have that kind of part in place. So that means that what is changing for the development team, it is quite significant, the shifts that have taken place, because we essentially in a short time kicking off an entirely new generation. So what you might end up doing is you might end up with a multitude of different sessions that continue to run as you keep on generating, because it takes about 20 minutes for you to generate a full end-to-end system like a banking CRM system. So the idea is that if you generate 3, 4, 5 of those at the same time, you might kick them off on the hour, have a 15-minute meeting, generate a few, have another 50 to review, have a 1 hour to check the process. So it's changing the entire interaction life cycle. With the current way that people use Agile is incredibly slow and long-winded, where you want to be able to compact that into 1-day deliverable cycles with 1 hour review processes. So in this case, the stories go to your hypothesis, your testing becomes your validation, your bug fixes are self-healing, your refactoring is prompt evolution, because you keep on getting your core and your reusable part of your infrastructure to be regenerated. You got your scaffolds that you create depending on what kind of documents you have for your designs and your design reviews, especially in the context of architecture. And then your story points become your token velocity. How many tokens am I using in order for me to generate the right kind of output that I want to generate? Again, what we can share with you essentially is this kind of environment. This is a notebook LM output. So for those interested, it's a video explaining the detail as well of how a lot of this works. But how do you create reliable autonomous systems? The ability for all of those steps to function together. And this was extracted directly from our own source code. So this is essentially how the core product works, inside the core kernel, what's under the covers. Okay, so this is basically the 4 phases. You got your spec-driven design, you create your entire generation and of your UML and all the documentation that you need. You get it through your reviews. In a typical enterprise setting, you still need those validated by humans. Normally, you have a human in a loop at that point. Your code generation can then happen potentially with 3 or 4 different kinds of designs that you want to generate, or maybe even different architectures. You can then decide if you want to target it for a cloud environment or not, or if you want to run it on-premise or in a local environment. And then you want to turn on or turn off self-healing to make sure that it gets itself to a point where it's a totally functional execution environment. So that just means that the spec-driven means that you've got all of the actions predefined. They can execute and make sure that your kind of new Agile is all about the fact that you can do a vertical validation across everything you're doing. Your code generation is automatic, and a lot of it has got to do with deterministic outcomes. So it'll help you quite significantly in generating, especially your initial systems that you want to have a look at. The other thing is you want to be able to check your cloud targets. You want to decide where you're going to push it and make sure that it supports that in the right way. And I'll show you that in a moment. And then you got your self-healing that at the moment in a public version is not available. It's only on the enterprise. So we set it up for you to, let's say you want to migrate from an on-prem into GCP or an AWS or Azure target. We get the self-healing engine to keep on checking the execution and making sure that it can fix itself. So that just means that the new team structure is going to shift quite significantly. And this is at the moment more of a kind of indicative view. I think that we don't have a very clear handle on how we think this is going to really play out necessarily, but your product owners is still going to be incredibly important. You need somebody that knows what it is that you need to achieve as an outcome, and that has got the human angle, speaking to people, understanding what you're going to do with it, where it's going to benefit whoever it's going to benefit. Your developers are going away now into what's called scaffold configurators. And that means that somebody that is a full stack person and technically capable is still as important as it's ever been. You still need those core. It just means that your army of generic developers that normally exist in many enterprises are typically not needed for this kind of deployment, because you can package the intellectual capacity or capability at least, and you can then create the execution capacity from your tooling. You don't need to go and have 5 parallel streams working on a slightly different functionality or bits of functionality for your outcome. You can generate most of those then automatically. And that means your architect, you're still going to need. You need somebody that understands how all the components fit together. And that means that even if you automate your entire cycle, you still need somebody that understands how things work and make sure that they can bring the pieces together. So this is kind of a summary of all of the parts just in one place. So that means that you get the hypothesis, the scaffold, you do the validation, you handle your edge cases, and then you optimize for your trade-offs. And while you do that, you just want to make sure that the IDE and the process that gets used for your existing AI tooling to enhance your capabilities in your existing tooling is that we generate the tasks, the settings, the memory system. We create that for you so that by the time you kick off your new tool, you don't have to go do all of that from scratch, because we tell it what was used in creating the scaffold. The same with Cursor and the same with your MCP service, because they're already configured and they're already set up if you want to access them in the context of the ecosystem environment. As an example, we can call an ecosystem recommender, or we can call an ecosystem code backend server to tell us what the requirement is. You can connect with any kind of MCP environment depending on what the concept is that you kind of working on at that moment. So here we can see that these are now completed. So that hospitality system is done. And in this case, we generated the code for this. So you'll see there, it shows there's a generated environment. It's done it once before. So let's just make this 2. If I now want to go and see how that code works, I will unzip it, and you'll then notice here that it's created the source code for the backend using a very, very disciplined approach. So you'll notice here that it's got controllers and services and repositories and models and workflows. It's created the full MCP backend infrastructure, routes. So it's essentially done all the work for you that an incredibly disciplined architect would normally do for you in the context of a technical deployment. And then the front end follows the same rules. There's the front end, where that what you saw there is the back end. Okay, let's just change that back there. Now, if I want to execute this particular app, and I'm just going to create a new terminal for now, and I go sh start. What it'll do when you start this up, I'm just basically running the start.sh script. Almost always in this kind of deployment, the database doesn't have to be installed from scratch. So it will rely on you running Docker. Okay, so I'll just have to turn on Docker. Let's just kill this app for a second. So Docker has started up. And that means that the backend database, in this case, it's a Mongo database, will connect to the Docker environment where the rest of the code will run local. There is an option that you can set in your project where whatever you generate, you can set your, let's just go back there. Let's just go to generate. You'll see there Docker Compose, so that it creates the entire Compose infrastructure for you. So you can basically build your project in its entirety. The other thing that you can do, if you do a serverless deployment and you target, let's say, AWS, Azure, or GCP, you can decide which target you want to create, and it will then create the Terraform scripts for you, and it'll essentially create the entire scaffold for you to deploy it into that cloud environment. The other thing is you got the synthetic data. So that means if a developer wants to check historically how things work, they would write, one developer would write stubs, well, somebody else would create some sample data. Now the synthetic data is generated from the core design. So that means it knows already where the dependencies are. It knows what's needed, what it's going to look like by the time the system runs, and we'll be able to get that kind of generated up front. So in this case, here's the app running. If I go and open up the app, you'll see that in this case, we've turned on the username and password. And let's just go check what it is. Let's just go back there. Okay, the security admin at example.com, and then that. So let's just go. This is admin at example.com. Password is that. And now there's my dashboard fully generated with no data in it. And you can see here that the banking one that I generated, we can do the other one maybe in another session going in the future, but maybe just quickly talk you through this. So for every single data point that is created, you'll see that there is the create new forms, including all of the dependencies, and it's got all of the categories and everything pre-created for you. You'll also then notice that it's got what the wireframe that we designed. There's the wireframe that we created that generated a form for us. It's got workflows. All the workflows are already created in workflow schemes, so you can go pick what kind of workflow you want to execute from the workflow. There are also enterprise forms where you can connect a whole lot of the different entities, including the analytics that go. And you see here that it's got a custom extension, and that custom extension was a prompt that I added to the one app, just to show that you can add through a prompt, you can extend what you want to extend. So if we go out of here, and you'll see there's a plugin here, you'll see the prompt here is that create a dashboard with a customer edit form. So you can basically write this kind of free form content and let it then extend your app based on what's already in the core. So that's kind of a whirlwind tour of how we see developer world changing. We see that the new developer lifecycle, is a manual coding is going to go to almost zero. A lot of documentation is going to go very low. And that means the whole concept around delayed validation, autonomous recovery, and the continuous optimization is definitely going to be a far more specific focus for the future. And you then have the capabilities to get that done. I think that's it for today.
Bye now.
Cheers.